Welcome to the show, everybody. And I'm sorry, I'm like Sir Cough a lot, but as you can see, the microdust is up in the air, and that led to my greatest discovery: how black holes work. Nothing can touch the black hole, and if it does, it rebounds so hard it goes straight into outer space again. Nothing ever goes in. That's that's the point. Nothing ever comes out. Nothing ever comes in. Why? Because if you were there, you would be shrinked beyond imagination. The sheer size and scale of this gargantuan thing would make you the tiniest. It's outrageous. It's outrageous how a black hole works. Now, listen. Just so you know, I really do know what I'm talking about. I want to talk about, well, I always talk about Jesus. Thank you, Jesus. I at least say thank you, Jesus, once. And it's about a neutron star. When a neutron star collapses, okay? We're going to take a little think about that. What is a neutron star? Well, it's the last thing before a black hole collapse. Okay? Black hole collapse is the last thing after a neutron star collapses. So, a neutron star is the last physical form of geometry in the 3D space. But do you know what happens to it when it tries to touch a black hole? No. Wait. Ooh. Reverse. Uh, uh. When a neutron star, it's made out of, just think of it as a big silver ball, heavy. A teaspoon weighs a mountain. This thing weighs as much as Mount Rushmore. See how light it is? This weighs as much as Mount Rushmore. That's a neutron star. Okay? Think about it. You got this neutron star, right? Boom. It's a sphere. It's a silver sphere. It's made out of mirror. Think of it as a mirrored ball. Yeah, that's a better analogy. Neutron star is a mirrored ball in 3D space, real geometry. It's the last point. You know what happens if you give it one more thin mint? One more little thin mint. Beaker time. It goes this huge thing that is at least 2 or 3 times as big as our sun, made out of silver, platinum, plexi, silver, like it's like plexi silver, solid diamond. That's what you could call it, solid diamond. This solid diamond sphere with zero defects. Well, there's got to be a little defect in it, but it spins so fast, it's more accurate than an atomic clock. Think about that. It won't go out of sync for billions of years. But anyways, you give it one little thin mint, and you know what happens? The thing goes foomp. It shrinks. It shrinks, and it turns into a black hole. So that tells you something. It's like a cosmic drip being sealed outwards. Because how does that collapse happen? And it happens very clean, and it happens very fast, and it happens very mechanically. It goes like this and turns into a black hole. Why? Well, don't question why. Think of the wonder and the beauty that you just witnessed without even witnessing it. Because you have a lot of faith, right? Yes, I have a lot of faith. And I think I saw something beautiful in my mind. If a neutron star tried to hit a black hole, the whomp would be the most gargantuan bounce in the whole galaxies of the whole universe if you put all of the energy together from all the matter in the whole entire universe. When that solid silver atomic thing weighing 10 to the 32 tons, imagine the kinetic energy when that black hole comes by and glances it. See, it does not go into the black hole and hits it. No. It doesn't go into the black hole at all. It can't. The only thing it can do is rebound. Rebound. All it can do is, okay, this is the neutron star, right? And this is the big supermassive black hole. You know what happens? Well, the big supermassive black hole comes by and it hits the neutron star, and you know what happens? You talk about rejection. You talk about Marv Albert times 10. Rejected. You talk about Dennis Rodman rebound. It is the ultimate cosmic gargantuan rebound. Anything that even comes close to the edge, see, you cannot reach the singularity because the singularity is locked behind this plexi shield. This plexi shield that's perpendicular to the parallel, and that's why light appears to crawl out of it. But it's not light crawling out of it, it's the black hole traveling and things deflecting off of it, like psh, psh. There goes a star, psh, there goes a little star, boom, there goes some Hawking steam, boom. Hawking steam is the best shave a black hole can get. Or Stephen Hawking. It's Gillette is the best shave Stephen Hawking can get. So what happens is any debris that touches that black hole becomes infinitely small. First of all, it becomes infinitely small, and then it spins up, and it creates a mechanical cascade reaction, and I call that the glow up. This thing starts glowing just like this. Look. Do you guys see that? That's the mechanical glow up. It's the exact same thing as a black hole. I swear to God. That's what you're looking at. And just think of it. The Planck floor, when you touch this thing, it's the Planck. It's the substrate. It's direct access to the substrate. We're right on time. We're going to finish under 10 minutes. This is direct access to the substrate. Now, the substrate Planck length is 10 to the 38 below. That means down there connects to up there, because a black hole, a neutron star is 10 to 38 in the 3D space of space-time. But the Planck is 10 to the 38 down there in Planck time. So I hope you understand that it's negative Planck time substrate, and it's positive 3D space, 10 to the 38 density per radii of, you have to calculate the squared radii of the rotational energies, and that becomes a net value. And that's what causes some dark energy. Some, I didn't say all. I didn't say I discovered all of physics, but I'm getting very close because you guys have been wrong for a very, very long time about it. But don't worry, I got all the answers, and I'm going to share them with you. So, remember, folks, nothing can touch a black hole. Why? Because it's 10 to the 38 substrate Planck length. It's like a lid. It's like a seal. It's like deflecting that octopus off the hull and sealing it shut. And then the little technicals come get axed off. You know what I'm saying? But anyways, thank you for watching the show. And that's what it's all about. I swear to God, it's called the Glow Up. And we'll talk more later. Thank you. Oh, by the way, I will accept all the awards. Don't worry. I will accept the Nobel Peace Prize. I'll give it to Brian Greene for free. I promise. I'll dedicate my Nobel Peace Prize to Brian Greene, my friend.